The next section we want to cover is the sequences and series section. And we want to define a sequence as the list of numbers in an order, a function whose domain is the set of positive integers. So we're looking at a specific list of numbers and they've got to be in a certain order. And we want to put in positive integers into an equation, and the output itself is the sequence. So the output that you see here is a sub n, where a sub 1 is the first term, a sub 2 is the second term, a sub 3 is the third term, and the input is 1, 2, 3, 1 for the first term, 2 for the second term, 3 to the third term. A couple things about an infinite sequence. It's something that never ends. It uses a triple period at the end to indicate it continues forever, and the set of all positive integers is its domain. So once again, this idea of positive integers is important. We're not plugging in negative numbers, even if it seems like we can get a valid answer for our solution. We only want positive integers that are the inputs, and then we receive an output. So I've got a sequence defined by 2n plus 3, and I want to find the first 5 terms. In order to do that, I would plug in 1 for n to find the first term. Then I would plug in 2 for n to find the second term. I plug in 3 for n to find the third term, and so forth. 4 for the fourth term, 5 for the fifth term. And this result that we get is a sub 1. This result we get is a sub 2, and this result we get is a sub 3. So if I were to take all the results of my sequence, and this one is an infinite sequence, so we would write the first 5 terms of this infinite sequence, 5, 7, 9, 11, and 13. Now, since I don't want to find every single piece of the infinite sequence, I don't need the dot, dot, dot afterwards, but if I wanted to verify, or to, not verify, but to show you that this is an infinite sequence, I would want to keep the dot, dot, dots. But since I'm limiting it to the first 5 terms, I don't need the dot, dot, dot after that. A finite sequence has a closed set of positive integers as its domain. So for example, it might only have n equals 1 through 10. And then my finite sequence would only have 10 terms. The nth term, or the general term of a sequence, is also called the rule of a sequence. And that's what we call a sub n. So in example number 2, we want to find the 6th term of the infinite sequence with the general term a sub n is equal to 3 raised to the n minus 1. Since I want the 6th term, I'm trying to find a sub 6. So wherever I see an n in my equation, I'm going to substitute it with a 6. So here, a sub 6 is equal to 3 to the 6 minus 1. So a sub 6 is equal to 3 to the 5th. So a sub 6 is equal to 243. So that's the first type of sequence that we're looking at, an infinite or a finite sequence, where we just plug in, if we want the 5th term, we plug in 5 for n. Following that, then, we get something called the explicit formula. The explicit formula is the rule or the equation of a sequence that gives the nth term as a function of n. And all that's saying is I want to come up with an equation where if I plug in 1 for n, I get my first term. If I plug in 2 for n, I get the second term. If I plug in 3 for n, I get the third term, and so forth. So right here, 10, 20, 30, 40. A sub 1 is the first term, a sub 2 is second, a sub 3 is third, a sub 4 is 4. What is the relationship between those 4 terms? Well, the answer to that is if I take a sub 1, I multiply by 10 to get my answer. With a sub 2, I multiply by 10, a sub 3, I multiply by 10, a sub 4, I multiply by 10. So my relationship is a sub n is equal to 10 times n. Where if I want a sub 1, I plug in 1. I get 10. If I want the second term, I plug in 2, I get 20. Plug in the third term, I get 30. My second example, 2/3, 2/9, 2/27, 2/81. What is the relationship there? And the relationship comes from the denominator. Here, this is 3 to the first, 3 squared, 3 cubed, 3 to the fourth. And 3 to the first matches with the first term, 3 squared meets with the second term, 3 cubed matches up with the third term, 3 to the fourth matches up with the fourth term. So my explicit formula for this is a sub n is equal to 2 over 3 raised to the n.